Lesson 3.3, Finding Complex Solutions of Quadratic Equations. How can you find the complex solutions of any quadratic equation? The best way is with the quadratic formula. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, investigating real solutions of quadratic equations. Complete the table. A squared plus bx plus c equals 0. So it looks like they're subtracting c from both sides. So we're going to subtract 1 from both sides. Minus 1, and we get 2x squared plus 4x equals negative 1. So we'll let f of x equal 2x squared plus 4x, and we'll let g of x equal negative 1. And the second one, we're going to subtract 2 from both sides. So we've got 2x squared plus 4x equals negative 2. F of x equals 2x squared plus 4x, and g of x equals negative 2. Here we're going to subtract 3 from both sides. So we got 2x squared plus 4x equals negative 3. So f of x equals 2x squared plus 4x, and g of x equals negative 3. The graph of f of x equals 2x squared plus 4x is shown. Graph each g of x and complete the table. All right, so let's graph the first g of x, which is negative 1. And let's see here, what do we got? Negative 1 would be right here. And that was supposed to have been, let's make that blue. That'll match the colors I put up. That's not right. There it is. And how many solutions does it have? Well, it has one solution here and one solution there. So it has 2 solutions. Now let's graph negative 2 and negative 2. It's going to be right here. And how many solutions does negative 2 have? It has one solution right here. So that is one solution. And then we'll graph negative 3. Negative 3 is right here. And it looks like we have, it does not cross it at all, so we have 0 solutions. C, repeat A and B when f of x equals negative 2x squared plus 4x. So we're going to repeat that. And let's see, we're going to add 1 to both sides. And we've got negative 2x squared plus 4x equals 1. So f of x equals negative 2x squared plus 4x, and g of x equals 1. Second one, well, while we're, let's see, that's going to be negative 2x squared plus 4x, and we're going to add 2 to both sides, so that will equal 2. F of x equals negative 2x squared plus 4x. So g of x equals 2. And the last one, negative 2x squared plus 4x equals, we're adding 3 to both sides, so that'll equal 3. F of x equals negative 2x squared plus 4x, and g of x equals 3. Equals 3. All right, good. Now, we're going to graph them. We're going to graph them. So let's graph negative 1. Negative 1 is, or actually it's positive 1. Let's graph positive 1 is right here. And as you can see, it crosses the parabola in 2 places. So we have 2 solutions. Let's graph the second one there. And that is at 2, so we'll graph it right across here. And that has 1 solution. 1 solution right there. All right, and that happens to be the vertex. And next, let's graph the third one. And that's at 3. X equals 3. And as you can see, it does not cross it, so there are 0 solutions. Look back at steps A and B. Notice that the minimum value of f of x in steps A and B is negative 2. Complete the table by identifying how many real solutions the equation f of x equals g of x has for the given values of g of x. So let's look back here. Let's look back. If it equals negative 2, if it equals negative, back one more. If it equals negative 2, there is 1 solution. If it's greater than negative 2, if it's up here, that means it's going to cross at least twice. And if it's less than negative 2, it means it won't cross at all. There we go. So if it equaled negative 2, there was 1 solution. If it was greater than negative 2, there was at least two solutions. Or there was 2 solutions. And if it was less than negative 2, there was 0. Now let's take a look back at step C. Notice that the maximum value f of x in step C is 2. Complete the table. So equals 2, greater than 2, and less than 2. So let's take a look at C. If it equaled 2, there was 1 solution. If it was less than 2, there was 2. And if it was greater than 2, it was 0. So equals 2 is 1 solution. Greater than 2 was 0 solutions. And less than 2 was 2. You can generalize reflect 1 for f of x equals ax squared plus bx, where a is greater than 0, f of x equals g of x, where g of x equals negative c, has real solutions. Has real solutions when g of x is greater than or equal to the minimum value of f of x. The minimum value of f of x is f of negative b over 2a equals a times negative b over 2a squared plus b times negative b over 2a equals a times b squared over 4a squared minus b squared over 2a, which equals b squared over 4a minus b squared over 2a, and that equals b squared minus 4a minus 2b squared over 4a, which equals b squared, negative b squared over 4a. And all they did was some simplifying here. Like here, they took an a out, so they got 4a. Okay, and then b squared over 2a, and then b squared over 4a minus 2b squared over 4a. So what they did here was they multiplied this term by 2, so they got 2b squared over 4a. And they did that to get a common denominator. They did that to get a common denominator, and that's how they got this right here. So f of x equals g of x has real solutions when g of x is greater than or equal to negative b squared over 4a. Substitute negative c for g of x. Negative c is greater than or equal to negative b squared over 4a, so they're going to add b squared over 4a to both sides, and they get b squared minus 4ac is greater than or equal to 0. They multiply both sides by 4a, and that gives them b squared minus 4ac. They just did that to get rid of the denominator there. Is greater than or equal to 0. In other words, the equation a squared plus b squared plus c equals 0, where a is greater than 0 has real solutions when b squared minus 4ac is greater than or equal to 0. Well, this looks real familiar. It's called the discriminant. Discriminant. Discriminant, and it is found under the radical in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, the discriminant is underneath the radical in the quadratic formula. All right. Generalize the results of reflect 2 in a similar way. What do you notice? What do you notice? All right. For f of x equals ax squared plus bx, where a is less than 0, f of x equals g of x, where g of x equals negative c. Has real solutions, real solutions when g of x is less than or equal to the maximum value of f of x. The maximum value of f of x is f of negative b over 2a equals negative b squared over 4a. So f of x equals g of x has real solutions, when g of x is less than or equal to negative b squared over 4a. All right. So we're going to start off, we're going to substitute negative c for g of x. And that gives us negative negative c is less than or equal to negative b squared over 4a. All right, then we're going to add b squared over 4a to both sides. So let's add plus b squared over 4a to both sides, plus b squared plus b squared over 4a to both sides. And we get b squared over 4a minus c is less than or equal to 0. We're going to multiply both sides by 4a. 4a times, and then times 4a. And remember, 4a is negative, okay? Remember, 4a is negative, so that's going to give you b squared minus 4ac is greater than or equal to 0. So whether a is greater than or equal or is greater than 0, or a is less than 0, whether a is greater than 0 or a is less than 0, b squared minus 4ac greater than or equal to 0 tells when ax squared plus bx plus c equals 0 has real solutions. Real solutions. Good deal. Finding complex solutions by completing the square. Recall that completing the square for the expression x squared plus bx requires adding b over 2 squared to it, resulting in the perfect square trinomial x squared plus bx plus b over 2 squared, which you can factor as x plus b over 2 squared. Don't forget that when x squared plus bx appears on one side of an equation, adding b over 2 squared to it requires adding b over 2 squared to the other side as well. Solve the equation by completing the square. State whether the solutions are real or non-real. So I'll let you do A, and when you go over A real good, and when you get back, we'll go over B together. So we want to write the equation in the form of x squared plus bx equals c. So we're going to subtract 7 from both sides, minus 7. And that's going to give us x squared minus 2x equals negative 7. Then we want to identify b. b is negative 2. So we're going to have negative 2 over 2, and it's going to give you negative 1 squared, which is 1. We're going to add 1 to both sides. So we add it to the left side, so we add it to the right side. That's going to give us x squared plus 2x plus 1 equals negative 7 plus 1. X minus, and that's going to be 2 divided by 2, which is 1. And that says x plus 2x right here, and that's supposed to be x minus 2x. And the negative 7 plus 1 is negative 6. So we're going to have x minus 1 equals plus or minus the square root of negative 6. Well, x equals, so we're going to add 1 to both sides. So x equals 1 plus or minus negative 6. So there are two non-real solutions. X, well, let's write it like this. 1 plus I times the square root of 6 and 1 minus I times the square root of 6. Reflect. How many complex solutions do the equations in part A and part B have? Explain. Both equations have two complex solutions. So both have two complex solutions. They always come in pair. Remember, it's plus or minus, so they'll always come in pairs. Because the set of complex numbers includes all real numbers as well as all non-real numbers. So they'll always come in pairs. Number 5. Solve the equation by completing the square. State whether the solutions are real or non-real. So what do we got here? We have x squared plus 8x plus 17 equals 0. So we're going to subtract 17 from both sides. Minus 17 minus 17. And that gives us x squared plus 8x equals negative 17. Then we're going to have, we're going to have b over 2 squared, which is going to be 8 over 2 squared. 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 to both sides. Add 16. And that's going to give us x squared. Well, let's see here. Plus 16. So that's going to make this x plus 4 squared equals negative 1. Negative 17 plus 16 is negative 1. Then we're going to take the square root of both sides. And that is going to give us x plus 4 equals plus or minus the square root of negative 1. Well, we know the square root of negative 1 is I. And if we subtract both sides, we get x equals negative 4 plus or minus I. So we have two non-real solutions. Two non-real solutions. Negative 4 plus I and negative 4 minus I. Those are our two non-real solutions. And let's take a look at this one here. We're going to add 7 to both sides. So we got x squared plus 10x equals 7. Now we're going to take and we're going to b over 2 squared equals, and this time we're going to have 10 over 2 squared. 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25 to both sides. And that's going to give us, b over 2, 10 over 2 is 5. So we're going to have x plus 5 squared equals 32. Let's go back to the blue here. And, well, let's take, this looks kind of crisp. We'll see here. No, I guess not. Blue. Red didn't take. So we got x plus 5 equals plus or minus the square root of 32. Now take 32. 32. If we take a 2 out, we got 16 left. Well, 4 squared is 16. So we're going to have x plus 5 equals plus or minus 4 times the square root of 2. Subtract 5 from both sides. You got x equals negative 5 plus or minus 4 times the square root of 2. And so we're going to have two real solutions. Two real solutions. Two real solutions. Negative 5 plus 4 times the square root of 2 and and negative 5 minus 4 times the square root of 2. Identifying whether solutions are real or non-real. By completing the square for the general quadratic equation ax squared plus bx plus c equals 0, you can obtain the quadratic formula x equals negative b plus or minus b squared minus 4ac over 2a, which gives the solutions of the general quadratic equation. In the quadratic formula, the expression under the radical sign, b squared minus 4ac, is called the discriminant, and its value determines whether the solutions of the quadratic equation are real or non-real. B squared minus 4ac is greater than 0, you get 2 real solutions. B squared minus 4ac equals 0, you get 1 real solution. And b squared minus 4ac is less than 0, you get 2 non-real solutions. Example 2. Answer the question by writing an equation and determining whether the solutions of the equation are real or non-real. So again, I'll let you do A, and when you get back, we'll do B together. B, a person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by the function a of w equals w times 50 minus w, where w is the width in feet of the garden. Can the garden have an area of 700 feet squared? So we're going to set a of w equal to 700. All right. And then we're going to multiply on the left side. So we're going to distribute the w inside the parentheses there. And we get 50w minus w squared equals 700. And then we're going to subtract 700 from both sides and rewrite it in. So we got 700. And we rewrote it in the form ax squared plus bx plus c equals. We rewrote it in that formula there. Okay, so we can put it in. We want to find the value of the discriminant. And the discriminant is b squared minus 4ac. And b is 50, so we're going to have 50 squared minus 4 times a, which is negative 1, times c, which is negative 700. All right, 50 squared is 2,500. 2,500. And then we got minus negative 4 times negative 1 is positive 4. 4 times negative 700, it will be minus 2,800. So it's going to equal negative 300. Because the discriminant is negative, the equation has 2 non-real solutions. So the garden cannot have an area of 700 feet squared. With these dimensions, it can't. That doesn't mean that you couldn't with other dimensions, but it can't with this dimension. Your turn. Answer the question by writing an equation and determine if the solutions are real or non-real. A hobbyist is making a toy sailboat. For the triangular sail, she wants a height in inches to be twice the length of the base B in inches. Can the area of the sail be 10 inches squared? Well, let's draw a triangle there. And let's see here. And that might be kind of close. Okay. So this is the base B, and the height will be 2B. Okay. Now, if you remember, the area of a triangle is area equals 1/2 base times height. So we'll just put that in there. Area equals 1/2 base, and the height is 2B. So we'll put 2B there. 2B. All right. And let's see, we can do a little factoring, or a little, simplifying. And 1/2 times 2 is 1, and then B times B is B squared. Now, can the area of the cell be 10 inches squared? So we're going to put 10 inches in here for A. At 10 equals B squared. Okay, subtract 10 from both sides, and you got 0 equals B squared minus 10. And I'm going to swap that around. So it looks like what we've been doing. B squared minus 10 equals 0. All right. Now, we're going to find the discriminant, and that's going to be the discriminant. All right. And that's b squared minus 4ac. And so b is 0. There is no b, so b is 0. 0 squared minus 4 times a is 1, and c is negative 10. All right. So 0 squared is 0. Negative 4 times 1 is negative 4. Negative 4 times negative 10 is positive 40. Because the discriminant is positive, the equation has two real solutions. So we got two real solutions. So the area of the cell can be 10 inches squared. So this area in here can be 10 inches squared. Finding complex solutions using the quadratic formula. When using the quadratic formula to solve a quadratic equation, be sure the equation is in the form ax squared plus bx plus c. All right, I'll let you do a by yourself, and we'll do b together. So we got 7x squared plus 2x plus 3 equals negative 1. And let's check. We've got ax squared plus bx plus c equals 0. So it's not in that form. We're going to add 1 to both sides. All right, so we have 7x squared plus 2x plus 4 equals 0. And then I like to, let's see, a is, b is, and c is. A is 7, b is 2, and c is 4. I like to do it like that. So we're going to substitute the values in for the different ones. And we've got negative b, which is 2, plus or minus the square root of b squared. So that's 2 squared minus 4 times a, which is 7, times c, which is 4. All over 2a, which would be 2 times 7. So that's going to stay negative 2. 2 squared, that's going to be 4, minus 4 times 7 is 28. That's like 112. Okay, so that's going to give us negative 108 in here, all over 14. So we've got negative 2, and let's see, 108, 1 and 8 is 9, so that's going to give us 3. We pull a 3 out, and what do we got there? 36. 3 goes in 36. Well, 36 is a perfect square, so that's going to give us 6i, square root of 3. And if you'll notice, 14 has a 2 in it, there's a 2 there, and 6 has a 2 in it, so we can simplify, and this will be negative 1 plus or minus 3i to the square root of 3 over 7. So the two solutions are negative 1/7 plus 3i, the square root of 3 over 7, and negative 1/7 minus 3i, the square root of 3 over 7. Now we got to check them. Check by substituting one of the values. So let's do the plus one in. So we're going to have 7 times, and we've got negative 1/7 plus 3i, the square root of 3 over 7, and that's going to be squared, plus 2 times negative 1/7 plus 3i, the square root of 3 over 7, and then we got plus 4, and we're going to check and see if that equals 0. All right, so we need to do the square, so we've got 7 times 1/49 minus 6i, the square root of 3 over 49 minus 27 over 49 plus 2 times negative 1/7 plus 3i, the square root of 3 over 7 plus 4. And we're checking to see if that equals 0. Now let's distribute the 7 in, and that's going to give us 1 over 7 minus 6i over 3 over 7 minus 27 over 7 plus, that's going to give us, well, that'll make it negative 2/7, so we'll make that minus 2/7, and that's going to give us plus 6i, the square root of 3 over 7 plus 4, and again, we're checking to see if that equals 0. Now let's see if we can clean this up a little bit. Notice this and this are the same thing, so we can cancel those out. Good deal. And now we've got, well, let's see here, negative 1/7 minus 27, that's going to be minus 26. That's going to be negative, that's going to be negative 28 over 7 plus 4, and we're checking to see if that equals 0. Negative, that's going to be negative 4 plus 4, and that equals 0, so it worked. 0 equals 0. Good deal. All right, your turn. Solve the equation using the quadratic formula. Okay, for 8, I like, what is A? A is 6, B is negative 5, and C is negative 4. All right, so I have X equals, and I'm going to just write it up, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so negative, and then what B would do is negative 5 plus or minus the square root of, that's going to be negative 5 squared minus 4 times 6 times negative 4 all over 2 times 6. So X equals, and that's going to be 5 plus or minus the square root of, and that's going to be 25 negative, that's going to be negative 24, 48. That's going to be plus 96, Okay. All over 12. And so X equals 5 plus or minus, and that's going to be the square root of 121. 121 over 12. The square root of 121 is 11, so I'm going to take that out, and I'm going to make that 11. Okay, good. So we have X equals 5 plus 11 over 12, and X equals 5 minus 11 over 12. So X equals, and 5 plus 11, that's going to be 16 over 12, which is 16 over 12, which is 4/3. And here at 5, that's going to be negative 6 over 12, which is negative 1/2. All right. So now we need to check. All right. And we got what here? Let's see. What do we got? 6 times, and let's just let's do 4/3. 4/3 is fun. Squared minus 5 times 4/3 minus 4, and we're checking to see if that equals 0. All right, so that's going to be 16 over 9, 6 times 16 over 9, minus 5 times 4/3 minus 4 equals 0. And let's see here. That's 6 over 9 there. Let's see, that becomes 2, and that becomes 3. 2 times 16 is 32 over 3 minus 20 over 3 minus 4 equals 0. 32 over 3 minus 20 over 3, that's going to be 12 over 3 minus 4. And let's see, does that equal? And 12 over 3, that's going to be 4 minus 4, which is equals 0. So that one works. Let's go over here and try number 9. Number 9. Let's see, A equals 1, B equals 8. Uh-oh. You got to subtract 2, so B is going to equal 6. And then C equals 12. All right. Let's see here. What do we got? We've got X equals -6 plus or minus the square root of 6 squared. 6 squared minus 4 times 1 times 12. All right. All over 2 times 1. Put it all in there first. So X equals, it's -6 plus or minus the square root of, and then 6 squared is 36. 36 minus 4, 36 minus 48, I'm getting -12. All right, all over 2. And so X equals, and 12, you take a 3 out, and that leaves you a 4. 4 is a perfect square, so you got -6 plus or minus 2 times the square root of 3 over 2. That's both got it. So X equals -3 plus or minus, and it's 2i because that was a negative, 2i. So that's going to give you I times the square root of 3. Now, over here, these are real solutions. That's 2 real solutions. Here, we're going to have 2 non-real solutions. So let's do our check. Our solutions are X equals -3 plus I times the square root of 3, and X equals -3 minus I times the square root of 3. So here's our check. I've got X squared, so that's going to be -3 plus I times the square root of 3 squared plus, and then I'm going to do 6 times -3 plus I times the square root of 3 plus 12, and does that equal 0? All right, so what do we got here? If we do this, -3 times -3, so we get 6 minus 6i square root of 3 minus 24 plus 8 I times the square root of 3 plus 12. And does that equal? That was supposed. That should have been 8, and that should have been 2 times negative 3 plus I times the square root of 3. And does that equal, well, that would be negative 6 plus 2I at the square root of 3. I did the other one, so I should have done that one there. All right, so now what do we got? 6 minus, that's going to be negative 18 plus 12. That's going to give you negative 6. That's going to give you plus 2I, the square root of 3, which equals negative 6 plus 2I, the square root of 3. All right, that works out. Good. Elaborate. Discussion. Suppose that the quadratic equation ax squared plus bx plus c equals 0 has p plus qi, where q is not equal to 0, as one of its solutions. What must the other solution be? So if it has p plus qi, it must have p minus qi as the other solution. The radical in the quadratic formula produces imaginary numbers when b squared minus 4ac is less than 0. Remember, also x equals plus or minus whatever's under there. Okay, so if you get p plus qi, you must also get p minus qi. Okay, qi being whatever q was, negative q squared. All right, so since the square root of b squared minus 4ac is both added to and subtracted from negative b in the numerator of the quadratic formula, one solution will have the form p plus qi and the other will have the form p minus qi. Okay. Discussion. You know that the graph of the quadratic function f of x equals ax squared plus bx plus c has the vertical line x equals negative b over 2a as its axis of symmetry. If the graph of f of x crosses the x-axis, where do the intercepts occur relative to the axis of symmetry? Let's see here. I'm going to need more room, so let's see here. The x-intercepts are the solutions of f of x. The x-intercepts are the solutions of f of x equals 0, which are x equals negative b plus or minus the square root of b squared minus 4ac over 2a by the quadratic formula. Writing the x-intercepts as x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a shows that the x-intercepts are the same distance the square root of b squared minus 4ac over 2a are the same distance, this distance right here, away from the axis. The axis of symmetry. With one x-intercept on each side of the line x equals negative b over 2a minus the square root of b squared minus 4ac over 2a on one side, and x equals negative b over 2a plus the square root of b squared minus 4ac over 2a on the other side. All right, so you've got one on, and the axis of symmetry is in the middle, okay? It's on the middle. Essential question, check in by why is using the quadratic formula to solve a quadratic equation easier than completing the square? The quadratic formula is the result of completing the square on the general quadratic equation ax squared plus bx plus c equals 0. As long as any particular equation is in the form of ax squared plus bx plus c equals 0, you can simply substitute the values of a, b, and c into the quadratic formula to attain the solutions of the equation. Okay. I guess because part of the work is already done for you. The quadratic formula, the quadratic formula is the result of completing the square. Completing the square. On the general I need to clean that up. Quadratic equation. Ax squared plus bx plus c equals 0. As long as any particular equation is in the form, you can simply substitute the values of a, b, and c into the quadratic equation quadratic formula. And obtain the solutions of the equation. And the reason why I had to change this from quadratic formula to, or quadratic equation to quadratic formula, because the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Whereas the quadratic equation in the general form looks like ax squared plus bx plus c equals 0. All right, so I had to be more specific there. Good job, folks. See you tomorrow in class and have a great evening.